time clock, depending on what kind of operation you want on the motor, and make sure the motor is operating at the required time. Many times I go and I audit, for example, a factory, and I see the compressor is working all the time, 100% of the time. It's working. And it doesn't make sense because you look at, there is no usage of the vacuum, pressurized air. Why the compressor is working? Either there is a leak, there is a sensor that is not working most of the time. The sensor is supposed to provide a feedback pressure to the motor and stop the motor when the pressure reaches the maximum value in the tank. But the sensor is broken. So make sure the sensor is working, everything is working correctly, so your electrical motor does not need to work at the time that it's working. And that's a huge amount of saving that you can get, basically. Sometimes the sensor goes back, your sensor is not correct, and by changing just a $20 sensor, you save the day. You don't need to do anything. You have, when it comes to energy management for the motors, you've got to check the scheduling of the operation, the duty cycle of the operation, the amount of the demand that is on the motor. Motor is a device that has basically the power factor is important because it's an inductance unit, right? It's an inductance unit. So you got to make sure basically the motor that is operating based on the design. A lot of times the design and what the motor is working is different. And to find out what was the design of the motor is very easy. You look at the nameplate of the motor, it's attached to the body of the motor. It tells you everything about the motor. It tells you even the power factor, it tells you how many RPM this motor is supposed to rotate. It gives you the whole history of it, like 10 lines. I talked about digital control. Okay, let's talk about heating and ventilation. So another source of energy usage is HVAC these days, right? We have almost every basically room control in this university. I don't think there is any room that is not controlled. Look at, there is no window here. So how are you supposed to control the air? Through the HVAC system. How are you supposed to control the freshness of the air? You know, in the old days, you just open up the window and the air changes. Now there is no windows in most of the facilities. Too many suicides, I guess. So what happened is, you have to exchange the air yourself. Exchanging the air, bringing fresh air from outside requires energy, because when you bring the air from outside, it's at outside temperature. You have to bring up the temperature to the room temperature, or lower the temperature to the room temperature, depending on winter or summer, and that costs money. Right? So HVAC is not cheap. Not only in terms of dealing with the amount of the energy that you're using to run it, but also the amount of the energy that you have to spend in order to make sure the air quality is correct. The number of the pollutant that you have in the air is in the amount of the standards, right? And most of the times, what we don't consider is by changing the thermostat 1 degree, how much effect do we have? What's the setup of the temperature at your home? Give me an example. What's the setup? What do you set? This is winter. What do you set your temperature?
I live in the dorms. It's centrally set.
Oh, it's who has access?
What is that?
What do you
I live in the dorms too. I don't think we had air conditioning for it.
Hmm?
No,
72? 72 for winter now, right? Okay. Yeah, 72. It's a sport. You guys are a sport. You know, it should be 68. In winter time, you're supposed to have a light jacket on. You're not supposed to have 72 degree and then walk with short sleeve everywhere. And somebody's paying for all of these short sleeves. Right? So winter time is supposed to be 68. Summertime, still your door, if you check it, is around 74. It's supposed to be at 80. And you might say, you know, 72 to 70 or 68, what's the difference? Actually, there are lots of charts to show you exactly what's the difference, and we're not going to really jump on that. You have charts that it tells you how many days of operation you have, and if you set back your thermostat 1 degree, 2 degree, 5 degree, 10 degree, how much energy you're going to save exactly. There is a huge difference between 70 and 72. Huge difference. It's not just 2 degrees. If you were living in the house, I would have challenged you to do that for a month, and next month, and you will see the differences between your bed. Especially if you're living in a cold area. You know, summertime, the same thing. Between 72 that most places fix to 78 or 80, there's a huge difference. And try to always notch it up a little bit on the cooling side and notch it down on the heating side. You know, it really doesn't have to save a lot of energy. Just use another layer. But when it comes to HVAC, beside the amount of beside the thermostat, what you have to check your fan, the cooling, the system is working correctly. You don't have loss of the air in the ducts. The lot of systems, they are duct-based. And what happens is that the cold or hot air somewhere in the utility room, by the time that it's supposed to come to your room, it passes through a lot of ducts, right? These ducts are old, they have holes in it, they are broken. Lots of air is passing through those. You lose them, right? So you got to make sure when you do energy auditing, go follow all of the ducts. Make sure that there is no leakage of the air in it. Make sure they are insulated. A lot of those ducts are not insulated either because insulation is cheap. It's expensive. But if the duct is too long, you got to insulate it. You can easily calculate how much energy you're losing on the surface area of the duct. And based on how much energy you're losing, you can calculate how much you have to pay for that money and convert it to, and compare it with the amount of money that you have to pay for your insulation. Insulation are not cheap either, but it's a comparison. It's all about comparison. When it comes to the fan, you have to make sure that the fan is operating at the working condition, the belts are all tight, you don't have any loose, basically, fan. And if the fan needs to be changed, immediately change it. Don't put up with the loose belt and fan. That's safe. That costs a lot of money. Temperature audit, we just talked about temperature audit, we lower the temperature, making sure the temperature are correct. Different rooms, different temperature. So one of the benefits of if you have a big facility to have, not to have one thermostat is that. Because when you have one thermostat, everything is set for that temperature. But in a big facility, different rooms, they have different temperatures. Look at here, for example, in the winter time, it requires to be 68 in a school office system. In a garage, you're expected to be 50. Lobbies, you're expected to be 65. Doctor office, 68. You know, so different locations, they have different temperature requirement, and by having different thermostat, you can reach that. This is for cooling season. So you can calculate the saving, as I said, based on how much setback you are going to have, how many days your system is operating. One of the things you see a lot in the HVAC system, it's called degree days. What does it mean? Degree days is simply multiplication of the number of the days multiplied by the temperature differences. If inside is supposed to be 70 degrees, outside average is 80 degrees, the difference is 10. If this difference is maintained on 3 months, 90 days, so I'm talking about 900 degree days, right? So multiplication of the number of the days, that temperature difference is existing. It's called degree days. Humidity is very important. A lot of places that you have to, here we live in Southern California, we don't deal with that high humidity. If you live in the Midwest area, for example, or East Coast, Florida area, there is high humidity. Partially one of the reasons that you are using HVAC system is to control the humidity basically, right? Humidity is a very, very important factor, and you have to spend quite a amount of money in order to basically increase the humidity as well. Now, with all of the modern system that you have all kinds of a computer system. You can attach all of these rooms, as I said, with wireless sensors to a mothership somewhere, and you can control all of the temperature. If this building is designed modernly, each of these passages you see has its own valve. So you can shut down this room, you have to let the room operate.